bilinear transformation. So now read the question carefully. So here, which is shown here, design a digital Butterworth filter, satisfy the constraints, some data which have been given here. So just see here with t equal to 1 second using bilinear transformations. So you can observe here in this exercise sum. So something which have been given in like in matrix formations. So that is, so here in this magnitude parts. So these things which is going to be called as magnitude parts. Okay. So this part which is going to be called as magnitude part. Okay. And the remaining part which is going to be called as frequency part. Okay. This is magnitude and phasor. So like that it will be determined. So from this magnitude part, we are going to be determining that attenuation value, and from this phasor part, we are going to be determined that frequency values. So these kind of sum, what we have to do means we will see the procedure how we can able to be determine that attenuation. So from the given data, so I'm writing that 1 by root of 1 minus epsilon square. Okay, 1 by root of 1 plus epsilon square, that equal to the value which have been given the first value. So that is 0.707. So this is the value 1 divided by root of 1 plus epsilon square. The next data from that magnitude 1 divided by root of 1 plus lambda square equal to the last value which is shown here 0.2. So this is that stop band. So this is pass band attenuation, and this is going to be called as stop band attenuation. So like that we are going to determine here. Next, from the frequency values. So we are going to be determine same pass band frequency and stop band frequency. You can see here, so which have been in this magnitude parts and frequency part, they have been mentioned in omega. So omega means this is digital Butterworth filter. Okay. So in the given sum, the omega which have been presented in between the variation means it is going to be called as digital Butterworth filter. So for a digital Butterworth filter, how we can able to be determined that the value means we are going to be represented into WP, that is going to be called as omega P, that is pass band frequency. The pass band frequency is pi by 2. So this value which are going to be taken here, the pass band frequency. So this is pass band frequency value from 0 to where we are starting pi by 2. So this is pass band frequency. Then stop band frequency where we are stopping here. So 3 pi by 4. This is the value stop band frequency. So these are the data which we have to pick up from that given data. So we need to take the 1 by root of 1 plus epsilon square, which should be taken 0.707. Similarly, 1 by root of 1 plus lambda square should be taken that 0.2. Then from this frequency part, this is going to be called as pass band frequency, and this value which is going to be called as stop band frequency. So now we are going to be determine this epsilon value and lambda value. So for that, I'm writing that 1 divided by root of 1 plus epsilon square, which is equal to 0.707. So from this data, I need to determine that epsilon square. So for that, I am taking that root of 1 plus epsilon square into the right hand side, and the 0.707 should have been taken in that left hand side. So here 1 by 0.707 using your calculator, that we are going to be get value is 1.414. And then now I'm going to be take square root on both the side. If I'm taking square root on both the side, so 1.414 square, that we are getting 1.99, and this root value which is going to be cancelled. Then this one value which is going to be moves to that left hand side. So I am going to be get 0.99 equal to epsilon square. Now I am going to be take root on both the side. Okay, I am going to be substitute root on both the side. So I am getting epsilon is equal to 0.99. So this is approximate value. So I am equaling into 1. I am going to be assume that epsilon value which is equal to 1. So from the given data, we have been determined that epsilon value. Similarly, So from the given data, we are going to be determine that lambda value. So for that, I am substituting this value. So 1 divided by root of 1 plus lambda square, okay, equal to 0.2. So from this data that we are going to be determine that lambda value. So this 0.2 which have been taken at the left hand side. So 1 by 0.2 is 0.5, 5 equal to root of 1 plus lambda square. Now I am going to be square on both the side. So I am getting 25 equal to 1 plus lambda square. This root which have been get cancelled. Then this one is going to be to go move to the left hand side. I am getting 24 equal to lambda square. Now I am going to be substitute that square on both the side. So I'm getting lambda equal to 4.898. Okay. So from the given data, we have been determined that epsilon value and lambda value. So this is our initial step. Then listen here, we are going to be using the transformation technique is bilinear transformation. For the bilinear transformation, there is a relationship between analog and digital frequency. According to this, we are going to be determine the value for the frequency. So here the frequency which have been given in digital form. So omega p, omega s. So for an analog ratio, how we are going to be determined means the omega p which is going to be denoted for his ohm p. Okay, so the ohm p formula which is going to be called as 2 by t tan of omega p by 2. Similarly, for an stop band frequency, this is digital. If you are going to be converted into analog, the formation will be ohm s. Then the formula will be 2 by t tan of omega s divided by 2. So according to this formula, we are identifying the value of analog stop band frequency and pass band frequency. So similarly, I am substituting the time period second t equal to 1 second in this formula. So I am getting that tan of omega s divided by, that is omega s value is 3 pi by 4. So 4 into 2 we are getting 8. Similarly, tan omega p, what is the value of omega p? Pi by 2. So pi by 2, yes, 2 into 2 is 4. This 2 will be cancelled. Yes ma, yes Ratnan.
Sir, in the value bilinear.
Yes, by using this bilinear transformation, so we are converting this digital frequency into an analog frequency. Okay, so according to that n formula, we are using that analog frequency values. For that, always for this digital Butterworth filter, we need to convert this digital filter into analog filter. Okay, so if you are substituting the digital filter, this is omega p. So that is digital passband frequency. Analog passband frequency means this is the formula 2 by t. So I'm writing here so far. So omega p will be equal to ohm p. Okay. Then the ohm p formula what? So ohm p which is equal to, okay, 2 by t tan omega p divided by 2. So this is the formula we need to determine that analog passband frequency values. So we are substituting the t value here. So we are getting 1. So this 2 and this 2 will be get cancelled. So remaining tan omega p. Omega p value is pi by 2. So 2 into 2, 4. We are getting pi by 4. So after that we are getting that value of substituting all these values. We are getting 2.414. So this is that frequency for ohm s divided by ohm p. So these are the initial data that we need to determine for an digital Butterworth filter using bilinear transformation. Okay, so you have been very clarified in this session. So from this given data, we have been find from this magnitude value lambda and epsilon. From the frequency value, yes.
Yeah, the given data எப்படி எடுத்தீங்க மட்டும் சொல்றீங்களா சார் ஒரு வாட்டி?
Yeah, yes. So you can assume that the first row which is going to be called as an pass band, so passing values, and the second row which is going to be called as ending value, that is stopping values. So in this highlighted section, which is going to be magnitude, you can see here mod of h of e power j omega. So omega which have been presented in this sum, so it is going to be called as digital Butterworth filter. Okay, this is magnitude part. So this entire session which is going to be called as magnitude part. So from this magnitude part, I'm writing that value as 1 divided by root of 1 plus epsilon square equal to, I'm getting that pass band magnitude 0.707. So this is that value that I'm getting. Okay, then 1 divided by root of 1 plus lambda square, the stop band magnitude stop band value is 0.2. So this is stop band magnitude. So from this magnitude, I'm taking these two values. Okay, I'm taking these two values. So from this value,
Sir,
I'm
upon the 100 value, sir.
this one is value is intermittent between. So pass band, there is an intermittent between from pass band to stop
Oh,
band.
continuous message, sir.
Yes, continuous
What is
signals.
sequence?
Array signal
Okay.
continuous.
Sir.
Similarly, you can see here from 0 to pi. Okay, we are passing some value of your frequency and stopping. So this is pass band frequency value and this is stopping from 0 to pi. Like this, there's variation. So from this frequency, we are determining pass band frequency omega p. Why we are substituting omega? Because this is digital. So here also it is shown here in omega. So this is digital Butterworth filter. So omega p equal to pass band frequency equal to pi by 2. Similarly, the stop band frequency, we are taking this value. Okay, for stop band frequency, we are taking this value 3 pi by 4.
Sir, digital, sir, doubt, sir.
Yes, ma. Yes.
Digital Butterworth தானே சார் கேட்டாங்க. எதுக்கு சார் அனலாக் இது கண்டுபிடிக்கணும்?
Yes, digital Butterworth, the digital frequency that have been given, but as a practical, there will be a frequency is going to be very for only analog. Analog only we can able to be tell that it is 50 hertz, 20 hertz, 30 hertz frequency variation will be there. There is no frequency for digital. Is it right? Digital there will be no frequency. Only code எப்படி போகும் ஒன்னே டைரக்டா இப்படி வந்து DC line will be so this the digital frequency value that you have been given. So this digital frequency value we are converting into analog. Why we are converting into analog means then only we can able to be take a sampling periods. Okay, in the first unit we have been studied about that sampling. So if you are taking sampling means then only we can able to be exact that original signal from that given signal. So for that only we are taking that samplings. So அதனால தான் நம்ம என்ன பண்றோம், we are substituting into an converting into an analog signals. Okay.
அப்ப எதுக்கு அப்பனா ஐ மீன் எது கேட்டாலும் ஃபர்ஸ்ட் நம்ம டிஜிட்டல்ல இருந்து தான் அனலாக் மாத்திக்கணும். frequency பேண்ட் பாஸ் பேண்ட் எல்லாமே.
Always we have to be convert that digital frequency into analog frequency, then we have to start the procedure.
Okay sir.
That is necessary. Okay. So next, according to the Butterworth filter steps, yes, right, Mas?
Omega is very எப்படி sir 3 pi by 4 னு கண்டுபிடிச்சோம்.
Yeah. So here I'm substituting here. Just assume that. Okay. Now 2 by t.
சார் பை கூட எடுக்கலாம்ல சார்? ஏன் சார் அத எடுத்தோம் நம்ம?
Yes, I'm right. 2 by t tan omega s divided by 2. So what is the condition? Substitute the condition t equal to 1 second. So if you are substituting t equal to 1 second, what you are going to be get in that value 2 tan omega s divided by 2. Similarly divided by 2 tan omega p divided by 2. Is it right? When substituting t equal to 1, is it right, Amma? Yes, students. Someone yes. Now this 2 and this 2 which is going to get cancelled.
Infinity நால எடுக்கலையா sir?
Wait, I'm going to this 2 and this 2 which is going to be get cancelled right now. Is that right?
Yes,
correct.
Sir.
Yeah. Then the remaining part is tan omega s divided by 2. What is that omega s value? Your omega s value is 3 pi by 4. Substitute the omega s value here, 3 pi by 4. So 3 pi by 4. 4 into 2 is we are getting 8. 3 pi by 4. 4 into 2 is we are getting 8. Remaining tan omega p. So omega p value is pi by 2. Okay. So we are substituting pi by 2. 2 into 2, 4, pi by 4. Is it right?
Yes, sir.
Yeah, now using calculator, it should be in radian mode, substituted tan 3 pi by 8 and tan pi by 4. We are getting that value is 2.414. If you are using calculator, you can able to determine this value. Whether you have been got 2.414?
Yes, sir.
Okay. Okay, shall we proceed
இல்ல
for the
சார்
next?
சார்
Mm.
இப்ப பாஸ் பேண்ட் வேல்யூ வந்து பை பை
சார் அந்த லிமிட் வந்து நம்ம 3 பை பை 4 எடுத்தோம்.
ஏன் 3/4 எடுக்கிறோம் சார்? ஏன்னா ஸ்டாப் பேண்ட் வந்து பைல தானே சார் முடியுது கடைசியா. அப்ப அதானே சார் ஸ்டாப் பேண்டா வரணும்.
You are taking that 0 and this pi. So stop band pass band அப்படின்னு பார்க்கும்போது pi by 2. So pi by 2 value is 0.5. So what is 3 pi by 4 value? 3 pi by 2 value is 1 by 2 value is
0.75. 3 pi by 4 1 sir.
Yes, hello. 1 by 2 value is 0.5. What is 3 pi by 4 value?
3 by 4 0.75.
So you are getting the value is 0.75 here. Is it right? So from this point we are starting the signal. We are passing the signal. The signal is traveling here. And at this point, 0.7, we are stopping that signal. So this is that signal. Okay. So for n, this is pi, and this is
okay, sir.
This is a magnitude part. So here we are starting that signal 0.5, 1 by 2. This is pass band frequency. Here we have started, and here we have been stopped. So at 0.75, that is 3 pi by 4, we have stopped signal. So this is pass band and this is stop band frequency. Can you understand this?
Okay.
If you are taking, if you are taking that mirror image of this, how we are going to be get? So this like this we will be get. So by seeing this diagram, we can able to be tell whether this is a low pass or high pass or band band stop filter. So this is a low pass filter. By seeing this diagram itself, we will be able to tell that this is a low pass Butterworth filter. Okay, so like that we need to determine whether that this is a low pass or band pass or high pass or band stop filter.
Sir,
Yes.
இப்போ நீங்க வரைஞ்சிக்க டயக்ராம் படி அந்த 7.5 வந்து ஸ்டாப் பேண்ட் ஸ்டார்ட் ஆகுதுல்ல சார்?
ஸ்டாப் பேண்ட் நிக்குது.
ஐ மீன் அங்க அங்க இருந்து தானே பை வரையும் ஸ்டாப் பேண்ட் இருக்கு.
ஸ்டாப் பேண்ட் கீழ. ஓகே.
அதான். அப்போ வந்து இங்க வந்து நம்ம ஃபர்ஸ்ட் ஸ்டார்ட் பேண்ட் வந்து 0ல இருந்து ஸ்டார்ட் ஆகணும். இந்த கொடுத்திருக்க இதுபடி.
எஸ்மா, இது வரைக்கும் 0 to 0.5 வந்து என்னதுமா உனக்கு? 0ல இருந்து 0.5 வரைக்கும் உனக்கு எந்த ஃப்ரீக்வன்சி சிக்னலும் இல்லை. இது வந்து ஸ்டாப். இது வரைக்குமே என்ன ஆச்சு? ஸ்டாப். எங்க நீ ஸ்டார்ட் பண்ற? 0.5ல ஸ்டார்ட் பண்ணிட்ட. இது பாஸ். இது பாஸ். இது ஃபுல்லாவே பாஸ். மறுபடியும் எங்க ஸ்டாப் பண்ற? இங்க ஸ்டாப் பண்ற. 0.75ல ஸ்டாப் பண்ற. சரியா?
ஓகே ஓகே.
0.7 வந்ததை டக்குன்னு ஸ்டாப் பண்ற. இங்க இருந்து ஸ்டாப். சரியா? அதுதான் பாஸ். இது ஸ்டாப். அதை வச்சுதான் இங்க எடுக்கிறோம். மேல இருக்கிற வேல்யூவை பாஸ்ன்னு எடுக்கிறோம் ஒமேகா பி. கீழே இருக்கிற வேல்யூவை ஸ்டாப்னு எடுக்கிறோம் 3 pi by 4. இந்த வேல்யூ எடுத்து அப்படியே இங்க சப்ஸ்டிட் பண்றோம். இப்போ ஓகேவா? கிளியரா? கொடுக்கிற டேட்டால இருந்து எப்படி வேல்யூஸ் எடுக்கணும்னு புரியுதா? அப்போ any other doubt based upon this, how to pick this value? Student, did you have any doubt? Shall we move for the next step?
Sir,
Yes, sir.
என்னமா?
Sir, அடுத்த டிஜிட்டல் கண்டுபிடிக்கணும்.
இந்த டிஜிட்டல் பட்டர்வொர்த் ஃபில்டர்ல கொடுத்த சம்ல இருந்து given டேட்டால லாம்டா எப்சிலான் வேல்யூ எடுக்கிறோம். ஃப்ரீக்வன்சி வேல்யூ டிஜிட்டல்ல இருக்கு, அது அனலாகா கன்வெர்ட் பண்றோம். this is ஃபர்ஸ்ட் ஸ்டெப். இது வந்து இனிஷியல் ஸ்டெப். இதுக்கப்புறம் நம்ம ப்ரொசீட் பண்ண போறோம் பட்டர்வொர்த் ஃபில்டர் மூலமா. we are going to be follow the procedure of Butterworth filter, step 1 to step 4. Shall we move for this next step right now? Yes?
Yes, sir.
Yes, sir.
Yeah, thank you. So now we are entering into that step for Butterworth filter. The step 1 is find the order of the filter. What is the formula? We know that the formula is n is greater than or equal to log lambda by epsilon divided by log stop band frequency divided by pass band frequency. So from this given data, we have been determined that lambda is 4.898, epsilon is 1, and pass band frequency and stop band frequency, which we have been determined in the previous step itself. We can see here, this is that a lambda value and epsilon value and pass band frequency and stop band frequency. Okay. So these are the given data. So next what we are going to be done, we are going to be substitute all these values in that above expressions. So therefore we are getting that n is greater than log. Instead of lambda, we are substituting the value 4.898. Instead of epsilon, we are substituting the value 1 divided by log stop band frequency by pass band frequency value is 2.414. Then we are getting that n is greater than or equal to 1.80c. What we have to do next step, we need to be round off to the next higher value. So we are getting n equal to 2. So this is our first step. We have been finished that first step. Then we are moving for the second step. What is our second step? Need to determine that transfer function. So we need to determine that transfer function h of s. So what is that order of the filter? The order of the filter is 2. So the for n equal to 2, when you are seeing that value in the tabular column for n equal to 2, we are getting s square plus root 2 into s plus 1. This is the value that we are getting. So now we are substituting it here. So that is h of s is equal to 1 divided by s square plus root 2 into s plus 1. So this is the value we are taken from that tabular column for n equal to 2. The second step have been completed. Then we are moving for the third step. What is our third step? We need to find that cutoff frequency. What is the value formula that we have been known? For the cutoff frequency, ohm C is equal to pass band frequency divided by epsilon power 1 by n. We will directly substitute in this formula because we know the value of epsilon. So we know the value of ohm P. What is that ohm P formula? 2 by T tan omega P by 2. What is that omega P value? Omega P value which is going to be an omega P value is pi by 2. If you are substituting pi by 2 here, we are getting that ohm P value is 2. Okay. And epsilon value is 1. So what is that n value? 2. N equal to 2. Okay. So therefore we are getting that cutoff frequency value is 2 radian per second. So third step have been completed. Then we are moving for that fourth step. So our fourth step is we need to determine that HA of S for a cutoff frequency of 2 radian per second. How we can able to determine? To determine that HA of S, we are going to be replace the S by S divided by 2. So why we are substituting that S divided by 2? So S divided by 2 means what? S divided by cutoff frequency value. Okay. So this is a low pass filter. Okay. This is an low pass filter. Okay. So this is an low pass filter. So as per our drawing that frequency value, we determined that this is a low pass filter. For a low pass filter, to determine that HA of S, we are substituting S divided by cutoff frequency value. What is that cutoff frequency value we get? We get the cutoff frequency value is 2. Okay, is it right? We get the cutoff frequency value is 2. So for that, we are substituting that HA of S. So in that H of S, we are substituting the value. So that is, we can refer that instead of S, we are substituting S by 2. Instead of S, we are substituting S by 2. Then simplifying that, we are getting that HA of S is equal to 4 by S square plus 2.828 S plus 4. So this is that HA of S. We have been designed that Butterworth filter of HA of S. Then the step 5 here, including here, in this step 5, what we are going to be do means we are going to be determine that h of z. So this is the new topic. So today that we are entering in this techniques. So find h of z by using bilinear transformation. Now only we are substituting that bilinear transformation procedure in that HAFS. So what we are getting that in HAFS, in that HAFS we are going to be substitute the bilinear transformation method. So we know that a bilinear transformation method. So what is that a bilinear transformation method? We are going to be replace the S in terms of 2 by T 1 minus Z inverse divided by 1 plus Z inverse. Simply what we have to do, எங்கெல்லாம் S இருக்கோ அங்கெல்லாம் என்ன செய்ய போறோம், S வந்து நம்ம ரீப்ளேஸ் பண்ண போறோம். எப்படி 2 by T 1 minus Z inverse divided by 1 plus Z inverse ன்னு ரீப்ளேஸ் பண்ண போறோம். So if you are replacing this S in that previous expression, we are getting that 4 divided by this HA of S will be converted into H of Z. So 4 divided by S square. Instead of S, we are substituting the value 2 by T 1 minus Z inverse divided by 1 plus Z inverse plus 2.828 into S. Instead of S, what we are substituting here? Replacing the S value plus 4. Then further that I am going to be substitute that T value. What is the T value according to the condition? 1 second. I am substituting that 1 second and expanding that expression. I am going to be get the value is 4 divided by 4 1 minus Z inverse square divided by 1 plus Z inverse plus 5.656 instead of S plus 4. Okay. Further, I'm expanding this expression. That is, I'm taking LCM. So I'm taking that LCM. The what I'm getting 1 plus Z inverse square, which have been taken into the numerator, in this denominator that I have been shown here. So instead of this formula, that is A minus B square plus A plus B square. So instead of this, I can going to write it in this form of A square minus B square. So
Sir, அது 1 plus தான சார் வரும் 1 plus Z inverse.
மேல yes right that is 1 plus Z inverse. Yes, that is 1 plus Z inverse. Similarly 1 plus Z inverse. Okay, then what I am going to be that this 1 plus Z inverse. So here 1 minus Z inverse square, that is A minus B square. So here A plus B square. Just I am expanding this according to the formula A square minus B square minus 2AB and I am substituting the 4 value into that. I am getting that expression which have been shown here. So here this minus 8z and plus 8z will be get cancelled. Then further simplifying it, we are getting the value here right now. So that is which have been shown here. So this is that value. So H of Z. So the final value of H of Z is 0.2829 1 plus Z inverse square divided by 1 plus 0.17 1.67 Z square. So this is that a final value of H of Z.